Hello again. We're going to be looking at problem number 4 found on page 221. This is in lesson 4.1 about congruent triangles. In problem 4 here, we are proving triangles congruent. Now, proving, sometimes these are called formal proofs because in a proof you list statements or things that you know to be true over here, and then on the right you must have a reason for each of those things that you stated on the left. It's almost like a lawyer going before a judge. Every statement that he makes, he's got to back it up with evidence. And so that's kind of what a formal proof is. So if you can see here, LM is congruent to LO and MN is congruent to ON. Now they're separating these out. Sometimes you can literally just list everything that is given, but that's where you always start. So they started with those two statements right here. And of course the reason is that it was given to us. And so you can see over here they've marked LM is congruent to LO. They've made the little tick mark there. They've also said that MN is congruent to ON. And again, they've made double tick marks to say that those two are congruent to each other. Now, since we're dealing with sides here, we can also know that LN, even though it belongs to the top triangle and the bottom, LN is the same line that belongs to both triangles. So if we say LN is congruent to LN, that may seem a little silly or obvious, but it helps us to establish that that side right there is congruent not only to itself, but since it belongs in two different triangles, that's going to serve to be important. So LN is congruent to LN. That's called the reflexive property of congruence. Anytime something's equal to itself, that's called the reflexive property. Now, then they go back and they pick up angle M is congruent to angle O and angle MLN. So M is congruent to O. They've got those marked. And then MLN is congruent to OLN, which is that little one there and that little one there. Those are congruent to each other. And again, that was given to us in the original. Now, the only angle that we don't know is angle MNL, which is this top one right here, and angle, let me mark those, I'll do triple, that is congruent to that. And the reason it is because if two angles, which was this one and this one, if you know two angles of a triangle, you automatically know the third. So if these two are congruent to these two right here, then the third ones have to also be congruent, okay? And that's called the third angle theorem. It just says if you know two angles of a triangle, then you automatically will know the third. And since these two are congruent to these two up here, then it makes the third ones congruent. Now you can say that triangle LMN, which is what you were trying to prove, is congruent to LON. And the reason is that's the definition of congruent triangles, because congruent triangles, the definition says that all three sides are congruent to all three sides of the other triangle, as well as all three angles of the first triangle is congruent to all three angles of the second triangle. And we literally just proved that one, okay? Now, as we look at the got it section here, we really don't have a whole lot of space here. I'll try to write small. But if you are given, let me pull that down just a little bit. If you are given that angle A and D are congruent, you're also given that AE and DC are congruent. And again, they have these marked over here. AE and DC are congruent. Angle A is congruent to angle D. So they've got those already marked. I know that EB is congruent to CD. They've got the double tick marks on that one. And that BA is congruent to BD. And they've got the triple marks. So it looks like we know all of the sides. All of those have been given. So what you would do is you would relist those. You know, angle A is congruent to angle D. AE is congruent to DC, EB is congruent to CB, and BA A is congruent to BD. And all of that was just given to us. Okay, I was just pointing out where they are. Now, there's two other things that we've got to be able to prove, and because we've been given all the sides and we've been given one of the angles. Now, the other one is that we know this angle right here, I'll do double tick marks there, is congruent to this angle right here. And the reason they are is because of vertical angles. So I could say that angle ABE, which is the left one, is congruent to angle CBD. Now you couldn't just say B because B belongs to two different triangles. So you have to write ABE and CBD, or DBC, I guess would be really the better proper way. Those are going to be congruent because of a rule that says vertical angles are congruent. I'm going to abbreviate. Vertical angles are congruent. Now, if angle A here is congruent to angle B, and angle D and angle B are congruent on the other one, then that leaves the third one, which is this one right here. This third one I'll make triple tick marks. Okay, they are congruent to each other, and you can just call this one angle E is congruent to angle C because of the same reason that this one did right here. If we know two of the angles of a triangle, then we automatically know the third. And so if these two are congruent to the other two, so if these two right here are congruent to these two right here, then the third ones would also have to be congruent to each other. And again, that's called the third angle theorem. Now if you look, all of the sides and all of the angles have been proven congruent to each other, so we can come along and say what we were trying to prove, that triangle AEB is congruent to triangle DCB, and the reason we're going to use is the same one as above. It's the definition of congruent triangles. Okay, so to truly prove a triangle is congruent, you have to prove that all three sides and all three angles of one triangle are congruent to all three sides and all three angles of its corresponding triangle. Now, as time goes by, we will show you a few shortcuts that you don't have to know all 6 parts, because mathematicians have found that if you know 3 of those 6 parts, you can prove triangles are congruent. We'll get into that in some of the other sections, but I hope this part was helpful.